Today, maybe we can look at the discovery of the subatomic particles. Okay. So, the subatomic particles, what do they include?
Electron, proton and neutron.
Electron, proton, and neutron. Okay. So, the proton and neutron together, they are located in which part of the nucleus of the atom?
Nucleus.
Nucleus, they are located. So, the structure of the atom was something that is always amazed the scientists. They are always thinking like what may be the real structure of the atom. So the model, how it has evolved, how the discoveries were made is a fascinating. So as part of your syllabus, there is the discovery of electron, nucleus, proton and neutron in brief. So we will just look in brief the discovery of the subatomic particle. Just we can revise this part. So when we look at the discovery of the electron, this setup that was used is known as the what?
Discharge rate tube.
Discharge rate. Discharge tube. So the discharge tube. And the rays that are emitting, these rays we call them as the
Alpha rays.
Alpha rays.
Cathode rays.
cathode rays.
Huh, rays.
Okay, cathode rays. These are the cathode rays. The question is why we say it is cathode. So make a simple diagram of this discharge tube. Okay. So they are basically two electrodes that are placed opposite to each other, connected to an external power source. Now the voltage is very high, in excess of the 10,000 volts, and inside this glass tube vacuum is generated. Okay, vacuum. So vacuum, whether we are able to create absolute vacuum, that is not there. So we are able to create in this particular experiment, for example, 0.001 mmHg of pressure. Okay, 1 atmospheric pressure is the normal pressure, no, of the atmosphere. Normal pressure is 1 mmHg. Here it is how many times less? 1, 2, 3. Is it correct? 1000-fold less or 100-fold less? 1000 times less. Multiply with 1000. 1, 2, 3. You will get 1. So 1000 times less of the pressure is reduced inside this discharge tube. So when how you will create the vacuum? You are going to pump out, no, something. You will use a pump and you will pump out that whatever is there inside. So inside it will create the vacuum. So the number of molecules of the gas inside the tube, they will be less or more than outside in the atmosphere.
Less.
Less in the
Less.
tube and more in the atmosphere.
Correct. Less, very few particles of the gas will be there in the discharge tube compared to the outside. Okay, this point is okay. Then when we switch on this power, one side is going to be cathode, one side is going to be anode. Okay, cathode, anode, cathode, anode. What is the charge or polarity of the cathode? Cation. We
It's a
have,
negative.
Negative charge.
let us see one by one. Huh? Cation. Cation is positive or negative charge?
Negative.
Positive.
You should never confuse
Positive.
cat ion, cat paw positive, cat paw positive, anion is negative. Okay.
Negative.
So cation positive, cation will mm, get attracted towards the cathode. Okay, that is the way you have to remember. Cat positive, cat positive. Okay, positive. This cation will get attracted towards the cathode. Okay, cation will move towards the cathode. You have to remember like that. Okay, and anion towards the anode. So if cation is positive charge, cathode will be the opposite polarity. Okay, because you know that opposite charges attract each other. Okay, remember like that. So cathode is negative charge, anode is the positive charge. So far, okay.
Yes, sir.
Okay, high voltage, low pressure. Okay, this is the cathode and anode. Now what is going to happen is from the cathode some rays will start emitting, and these rays will move in a straight line towards the anode. Okay, so when we look in this experiment here, okay, the voltage here, they is applying the voltage, and then you can see that, but when he is using the magnet, okay, that will move up and down. So otherwise it is moving in a straight line. Okay, so we know that these rays are moving from cathode to anode because these rays are starting from the cathode. They are known as the cathode rays. And we want to know whether this, what is the nature of these rays. If you are moving, if you are using some kind of magnet, or you are using, say, polarity, some other kind of positive and negative charge electrodes here away, because they will also create magnetic field, no? From that also you can know that what is the charge of these rays. So from that it is known that it is having a negative charge. Okay, and further experiments it was known that the mass of this electron is very negligible. Okay, so electron, it is a electron beam, you can say it is an electron beam. So what we see in the old television sets, okay, it is known as that CRT tube. They used to say CRT tube, black and white TV. Okay, Dabba TV used to be there. So that beam was the electron beam. Cathode rays were used. There also same principle. Electron microscope. What is that rays? Beam of electrons is passing through. They are nothing but again cathode rays. Okay, electron beam. Okay, so using this discharge tube, what could be identified? Electrons could be identified. These electrons were traveling as a rays, okay, and they are having the negative charge. Okay, now the discovery of the proton. In this one, you have any doubts? It is clear. Discovery of electron. Okay, any doubts you have in that one? Fine.
Yes, sir.
Okay, now we are moving to discovery of proton. So what we saw this one is also a similar discharge tube experiment. Okay, it was performed by Goldstein, and the rays he identified were not the negative charge rays but the positive charge rays. So what is the modification that was done by him? What is the difference in the setup? The same way there is a cathode and anode, okay, and will be applying a high voltage across it. But only difference is that here in the cathode there were some perforations. What you are seeing here, no, it is this where this you are seeing this glow, this reddish glow. This metal is having some openings, no, like this long. It is cut. Hmm. So these kind of slits or openings are there in this cathode. So we say it is a perforated. Okay, perforated, something like a mesh, something like a what you say jali. Okay, so from the anode, okay, similar 10,000 volts, low pressure, okay, everything this to setup is same. Difference is perforated cathode. Now what is happening? You are able to see this greenish glow in the center, no, this one you are able to see what I am trying to point out. This
Yes,
greenish,
sir.
this greenish beam is there. That greenish beam is the cathode ray. Okay, it is the cathode ray. The cathode ray will move from cathode to anode. Okay, but inside we have these gas molecules. No, when this electron beam hits the gas molecule, so consider, for example, that we are using some kind of gas like say neon gas. Okay, neon gas. In some advertisements you will be seeing that neon tubes will be there. They will be very colorful tubes. Okay, they will be written in advertisements, neon bulbs. So basically what is happening is when the electron beam is passing and it hits this gas molecule, it will eject an electron out of it. Okay, then what is going to happen? You get a charged particle. Okay, charged ion. What kind of charge you will get on that ion? Electron is removed.
Positive.
You will get positive charge. Okay, positive charge ions will be formed. Positive charge ions are being formed. Okay, these positive charge ions, whether they will attract towards the negative charge cathode or positive charge anode,
So it will attract toward cathode rays.
it will
Negative.
it will move towards the
Attract towards the cathode ray.
it will move towards the cathode. It will move towards the cathode. Moving towards the cathode. Okay, and because these are having these holes, they can pass through it. Okay, they can pass through it, and here they will give that certain glow they will give. Okay, that is the which appears in the reddish color glow. So basically what is happening, setup is a bit different, like different scientists have done this discharge tube experiments little bit, everyone's setup is different, but basically here what the point you have to remember, cathode ray,
Attraction.
cathode ray is a beam of electron. Electron beam. And anode ray is what?
Positive
Positive what? Is it protons?
Beam
beam.
of positive ray.
Is
Beam
it the
of positive
protons?
ray. Yes. No, sir.
Yes, sir.
No, sir. Yes, sir. It is a proton.
Cations.
Hmm. Hmm. Just you can think about it. Just I have explained now. You think whether it will be proton. So I think in textbook also it is given the anode ray consists of positively charged particles called protons. Okay. Unfortunately, that is not correct. Okay. This is the positively charged particles. That is the whatever the cations are there. These are the cations. Okay. Cation. Okay. These rays are made up of these charged gas particles which are cations. Okay. So if you change the gas, the property of that cation, the property of the cathode ray, sorry, uh, of the anode ray will change. Okay, the property will change. Okay, so how they are different? The anode ray and cathode ray. Cathode ray consists of the electron beam, and the anode ray consists of the charged particles. Charged particles. Next, Rutherford performed the experiment of the gold file. That is the discovery of the nucleus.
Nucleus.
Nucleus. Okay, so Thomson discovered the
Electron.
electron, and Rutherford
Nucleus.
did the nucleus. Okay, and proton
E. Goldstein.
was the gold. Now the discovery of the nucleus, scientists were believing that the atom, how it is looking like a plus and minus charge, everything is like some kind of what you can say plum pudding model, means what that they are all mixed together. Okay, something like this was what they were imagining at that time. So Rutherford, he did the experiment. He passed the alpha particles, that is the alpha rays. Okay, alpha rays are made up of the helium. Okay, He2 plus. So if you pass that alpha rays, which are radioactive rays, through a gold foil, which is so thin, 1 micrometer thin. Okay, very thin. So 1 micrometer thin means that hardly not more than 3, 4 like that atoms will be there in the thickness. Okay, gold itself is a heavy atom, no? So the thickness will not be more than 3, 4 atoms like this. Okay, the thickness. So now if this model is correct and you are trying to pass these rays, then 99% of these rays should bounce back, no? But what he observed that 99% of the rays are simply passing through and only less than 1% are bouncing back. So based upon this, what he has told that most of the atom is empty, only small amount, okay, is the whole mass of that atom is there in the nucleus. Okay, that is what Goldstein has told. Okay, so that is the overall experiment setup in which when you are passing this alpha rays, most of them are passing through because most of the atom is empty, and whichever particle is hitting the center of the atom, the nucleus, only that few are going to deflect by a small angle. Okay. With this, he was able to predict that this model is correct and this model is not correct. Okay. That is how he discovered the nucleus. Because earlier model, do you think this is a nucleus? There is no nucleus in this old model, no? So this is how the nucleus was discovered by the Rutherford. Okay. So this is clear.
Sir,
Yeah.
sir, alphabets are made up of positive charge particles,
Helium,
ions.
you see, helium, He24. Okay. So its atomic number is 2, mass number 4. So He2 plus means we are removing the 2 electrons. Okay. We are removing the 2 electrons. So it is gaining the 2 plus charge. It becomes He2 plus. Okay.
Sir, but helium is a noble gas, no?
Yes, it is a noble gas.
Sir, then how it can lose electron?
So this one is in a radioactive experiment. Okay. When we say alpha rays, okay, for any removal, for example, of the electron, there is a requirement of energy. Correct. Whether that energy is what you can tell normal range or above normal range, that is only a question. So mostly what happens that in normal conditions it may be that energy is very high, but it is not that it is never possible, no? You are getting my point. It is possible, but under normal conditions not feasible. That is not feasible. So we say that it is stable. But if you are using special conditions, very high energy you are providing, that is possible. Okay. Next,
Yes, sir, understood.
neutron. So this neutron is again, these discoveries were possible. The second part, that is the discovery of the nucleus and that of the neutron, were possible by the discovery of radioactivity. Okay. Before that, the experiments were carried out in the discharge ray tube experiments. Okay. All discharge tubes were used. But after the discovery of the radioactivity, it was possible to discover the nucleus and the neutron. So neutron by Chadwick. Okay. It was way later, 1932. So what he has done, he has just passing the alpha rays. Okay. There is through beryllium. Okay. So when you are passing this alpha rays through beryllium, what is happening? Alpha itself is a heavy. How many it is having? Already two protons are there in its nucleus. Okay. Hydrogen, helium, lithium, beryllium. Four, no? Beryllium atomic number 4, helium atomic number 2. So when helium you are using atom to bombard the beryllium atom, then what is happening? It is able to knock out some neutrons from this beryllium. Okay. So Chadwick observed that some neutrons, some rays are coming out of this, some particles are coming out of it. Okay. So use a paraffin film, paraffin. Okay, it's nothing but that wax, normal wax kind of thing. So even a paraffin is able to stop this rays. Okay. And instead he is able to see some positive charge Okay, protons are coming on the other side. So during this experiment, we will not go much into detail, but here main thing is that these rays were not deviated by the positive or negative pole. Okay, if you use a magnet or if you use a opposite polarity, okay, electrodes, these rays are not deviating. Okay, so cathode rays and anode rays, okay, they are having charge, and therefore in electrical field or magnetic field they are deviating. But these neutrons, they are neutral, they do not deviate. Okay, so because it is neutral, this is given the name as the neutron. Okay, so that is for the discovery of the neutron. Okay, any doubts you have, you can ask.
Sir, I have doubt in discovery of protons. Sir.
Okay, you can ask.
So in the discovery of protons, the rays are passed from cathode. The rays are passed from cathode side. Then, sir, if we are going to put a magnet in above that, then, sir, this is negative and that one will be positive. Then both are attracted to each other. Then how in between the between between that, sir, electrons, sorry, protons are forming. Sir. That I am not able to know.
Okay, I think once again you will have to frame your question, but I have taken the attendance, sir. Okay, those who want to leave, they can leave. Okay, someone has a couple of doubts, we can maybe for 5 minutes we can look at the doubts and then we'll close. Okay, yes, can you reframe your question?
Okay, sir. So the rays are passed from cathode side.
In the proton one you are telling, no?
Yes, sir.
Okay.
So the rays are passed from cathode side. Then that ray are attracted to anode because that this one is negative and that one is positive. Sir. Then how in between, sir, positive ions are formed, sir, which is known as
Yes,
protons.
it is simple like this. You see, cathode. Okay, here cathode is there and here anode is there. Okay, so first which ray is passing here? It is nothing but the cathode ray is passing. Okay, and cathode ray is nothing but beam of electrons. So when this beam of, we are not showing in the diagram. Okay, in the diagram we are only showing here positive ones, but actually the cathode rays are there, no? Cathode rays are forming. These cathode rays will go in a straight line, and when they hit these gas atoms, okay, when they hit these gas atoms, these are special conditions, very high voltage, very low pressure. Okay, under these special conditions what happens, even the noble gases, from that you are able to eject the electron and you are able to get the positive charge ions. Okay, because these positive charge ions are formed, these positive charge ions, very few molecules of the gas are there, no? So it is not able to form any beam here. Okay, any color, any beam you are not seeing here, but the charge particles are there. Now these charge particles, they are attracted towards the cathode, positive. Okay, cations are attracted towards the cathode. When they are reaching this cathode and this cathode is having these holes, they are able to pass through that cathode. Okay, when they are passing through the cathode on this other side, okay, they are giving this kind of glow. Okay, reddish glow we are able to see. So that is visually we are able to see that kind of effect here. So that is what we are telling, this is a special kind of ray, different kind of ray, that is the anode ray, because it is coming from the anode. Okay, but basically from where it is coming? It is not coming from the anode. Okay, so
Yes, sir.
these are a bit, deeper points, but what is happening is for class 8 and also for most of the part class 9, this much detailing is not done. So just to make the things very easy, okay, to understand, not much complicated, simply what people will say that cathode rays coming from cathode, anode rays coming from anode. Okay, that's all. So here cathode rays, they are having the negative charge, anode rays are having the positive charge. That's all. Okay. So it's part of your experiment. So basically, one setup we have to understand what is the property that you have seen. Okay. Anything else? Okay. So I will see you all in the next class. Huh? Thank you.